Okay, in this lesson we're going to learn about piecewise functions. And we will learn how to evaluate a piecewise function and graph it, as well as what they are, of course. So I'd like you to take a moment to evaluate this picture and see if you can figure out what that last statement would be equal to. Okay, what are piecewise functions? So a piecewise function, as you might guess, is made up of pieces all put together. And so you can have two or more functions, and each of those functions would have a domain all put together to make one function. Okay? So what do they look like? So here is the function f of x, and it has two parts. You can see right here this part and this part. And so how do you know what you're supposed to do? Well, it says here f of x is equal to x squared minus 1 if x is less than negative 2. So if x is less than negative 2, you're going to use this top part of this function, this top piece. If x is greater than or equal to negative 2, then you're going to use 5x plus 3. So it really depends on where you're at. So we use that domain to try to evaluate the function and figure out where to plug in. So here's what we're talking about. Let's look at this first one. It says find f of negative 5. So x is negative 5, which is less than negative 2. So that means we are going to use this part of this function. So I'm just going to plug in negative 5 into x there, and so we would get negative 5 squared minus 1. And then negative 5 squared is 25, minus 1 would give me 24. So f of negative 5 is 24. All right, so you just evaluated that function at negative 5. All right, so now let's try, I'll get rid of some of this so we can see a little bit better. Let's try doing this now when we look at it at negative 2. In other words, find f of negative 2. So negative 2, it says we're going to use this bottom one since it says we use this when x is greater than or equal to negative 2. Well, this is negative 2, so we're going to use that one. So I would plug in and I would say, all right, 5 times negative 2 for x plus 3. And that is negative 10 plus 3, which would be negative 7. So f of negative 2 is equal to negative 7. All right, and then find f of 7. So let's see, which domain would we be looking at? 7 is greater than negative 2, so we're going to still look at this one, and that means we're still using this function, or part of the function. So 5 times 7 plus 3, which would be 35 plus 3, so 38. Okay. Now, I'm going to have you try and see if you understand how to do this. So I want you to look at this one. It has 3 pieces to it. And go ahead and find g of 2, g of negative 1, and g of negative 6 using this function. Okay, how'd you do? All right, so next thing I want to go over is how do we graph a piecewise function then? And this can be a little bit challenging. So I'm going to take our time with this first one. All right, so again we have, in this case, 2 pieces. It says f of x is equal to x if x is greater than or equal to negative 3, and f of x is equal to negative 2x plus 1 if x is greater than negative 3. Okay, so let's start with the top part. Let's go purple. Okay, so remember f of x is another fancy way of saying y. So this first part is really like y equals x. So if you don't remember what that looks like, you could just do a table, xy table, and y and x are the same. So if x is 1, y is 1. If x is 2, y is 2, etc. So really, let's see, 1, 1, 2, 2, 3, 3, etc. on down the line there. So now I really want to take this. Let's see if I can. Okay, and now I want to say, all right, that function, there's y equals x, or f of x equals x, but I'm only supposed to use this when x is less than -3. Okay, so now, let me switch colors here a little bit. -3 on the graph, when x is -3, is right here. Well, that's kind of a bad line there, but it's this line right here. So what I want to do is I only want to keep everything that's less than or equal to that. So everything to the left of this red line, I want to keep that part of that purple line. So really I'm going to erase everything to the right of that. Okay, and I'm only keeping that left purple piece. Okay, and I'm actually going to get rid of this too, because that's pretty ugly. Okay, now we want to say, I want to keep it's less than or equal to, so at -3 I should have a closed dot, because I want to keep -3, and so I want to put an arrow on the end of that one. Okay, so that's that part. I'll switch colors here to, I don't know, let's go that one. All right, so now the second part is y equals -2x plus 1. Okay, so remember this is slope-intercept form, so this is my slope, this is my y-intercept. So when I'm graphing those kinds, I want to start with my y-intercept and put a, on the y-axis, put a dot at 1. And my slope is -2. So remember that's rise of -2 and a run of 1. So that means go down 2 units, 1, 2, and over to the right 1 since it's positive. So now I want to do that a couple of times, down 2 over 1. So I have a number of dots there. You might even want to go back up to an over 1 and continue that pattern. So then you kind of have an idea. You can see it across there. So now the question is, can I get this through these dots? Okay. Now I have that, but this says we're going to keep when this line for everything when x is greater than -3. So once again, my -3 is this line right here, right? So I want to keep everything bigger than that. So that would be to the right of that. So I want to erase this part of it. Okay, and then I can kind of get rid of this line too. Now, I want it's greater than or equal to, so I'm going to need an open dot at -3 there. Okay, so now here is my graph. Notice it's 2 pieces, and we go from there. And we've just graphed our first piecewise function. All right, that's it for today.